So the really cool part, let me rephrase that. One of the really cool parts about today's lesson, because there's multiple, is that reinforces what we talked about last time. Okay? That's the first really cool part. We'll see some more really cool parts in a second. What if this was the problem you were given? What would you do first? Common factor? Is that what you were trying to say? Oh, okay. Okay, fair enough. But how about if we go with my answer? Is that all right? Factor out a common factor. What's common? What else is common besides x? X to the third, right? If they both have an x, we want to see what's the biggest one that I can take out. And usually it's going to be the smallest one. Isn't that weird? Okay, just get over it. You'll be fine. Okay? If I factor out an x to the third, what do I have left? If I divide out an x to the third, what do I have left? X. If I divide out an x to the third, what do I have left? Okay. Now, we talked about that last time, right? Factoring out a common factor. Can I do anything else with that? No. Okay. What if it said 2x plus 8? That's like super easy, right? Factor out a common factor again, right? What's common between 2 and 8? 2. What's left when I divide this term by 2? X and plus 4. Good. So, here's the really cool part. Oh, I wrote it down wrong. Dang it. This is supposed to be a minus, because then it's not so cool. If this is a minus, what's this? A minus. Now, here's what's cool about today's, is that is the problem. That's the problem. And what we do is we just ignore the last two terms and just look at the first two terms, factor out something that's common. And then we ignore the first two terms and just look at the last two terms and factor out something common. And what do you notice? What's the same? So they have something else in common, right? Both of these terms have something in common. What is it? X minus 4. Factor it out. What's left when I have when I factor out an x minus 4? X to the third. What's left when I factor out an x minus 4? 2. Done. So it looks way harder because there's how many terms? 4 terms. How many did we deal with last time? Only 2, right? We did difference of squares, sum of squares, difference of cubes, sum of cubes. All of that are only 2 terms. God bless you. All of that, all of those kind of factorings are only 2 terms. They're binomials. We start with binomials, right? We go from 2 terms to 4 terms. Usually people freak out. Except I'm like, look, it's really only 2 terms. Look, it's really only 2 terms. Once we do that, do they have something common? Now, if this was a plus, like I accidentally wrote in the beginning, what would you do? Stop. Can't do anything else. Nah, fam. Okay? But if they do have a common factor here, which is our goal of factoring by grouping, which is what this is called today, but you already knew that because you already wrote it off the sideboard, right? You wrote your student-friendly learning objective off the sideboard. Yeah? Okay. So this is called factoring by grouping. How are you going to know it's factoring by grouping? There's 4 terms. When there's 4 terms, we're going to factor by grouping. We're going to group the first 2 together and get that far. Then we're going to group the second 2 together and get that far. And then we're going to look and see, do they have a common factor? And if they do, factor it out. What's left? Yes? Yes, sir. Yeah, if this was a plus, like I said, we would just stop right there. Okay? And it's not even really not fam, because we did factor something out, and we would just leave it right there. Okay? So, I'm going to do another one for you that is both easy and the opposite of that at the same time. x to the third minus x squared minus x plus 1. So there's a couple different ways you can do this. If you're a color person, like I am, I'm going to go and underline my first two terms, and I'm just going to look at the first two terms. Some people earlier today, they were putting parentheses around these two terms, or just underlining it just in their regular pencil. That's fine as well. Okay? I'm going to look at just those two terms. What do just these two terms have in common? X squared. If I factor out an x squared, what is left? X minus 1. Okay? Now, I'm going to look just at the second two terms. Now, looking back at this example, what do I need again? I need to have a common factor here, right? So, in this problem right here, I need a parentheses that says what? X minus 1. So what do I need to factor out from this second set? Oh, a negative 1. Okay? What if this was already x minus 1? I don't factor out anything? I always have to factor out something. That's exactly right. I have to factor out a 1. I always have to factor out something. Okay? Even if it's just a 1. Even if it looks like it's already supposed to, I factor out a 1. Now, this one doesn't look like it's supposed to, does it? So I factor out a negative 1. What's left when I factor a negative 1 from each of these terms? X minus 1. Do they have a common factor? What is it? X minus 1. So if I factor out x minus 1, what is this? What do I have left in this term? X squared minus 1. So I'm not done. Remember a second ago I said it looks really easy, but also the opposite at the same time? I'm not done. It looks really easy because all these coefficients are 1, right? Woohoo, we got it. How do I know I'm not done? Oh, I can still do something with this, can't I? What is that? What does that mean? Difference of squares. It's a difference of squares. Now, why didn't I do that up here? It's not the difference of squares. It's not even the sum of squares. Oh, it might be the sum of cubes, is it? Is 2 a cube? No. So that was why I was done up here, right? There's nothing else I could factor. In this one, there is something else I can factor. So I have this one, because it was already there. And then for difference of squares, I get 2 binomials, right? What are my 2 binomials? Do you remember? X minus 1, x plus 1. That's exactly right. Now, just giving you a hint, if you have this happens to be an odd number and you happen to check the back of the book, it may very well say this. Why would it say that? Because there's 2 of those, right? So they just squared it. This is a perfectly acceptable answer. Just so you know. Yes, ma'am.
Why wouldn't the one in this box be a better answer because it's simplified?
This one?
Why is the one in the box
Uh-huh.
not the best answer? Like, why wouldn't the book have that answer if it's not if the bottom one's not simple?
The book likes to use as less ink as possible, and this one uses less ink than this one. Yes, sir. Say again? Oh yeah, absolutely. Both of these are right answers. This is one more step that you would have to go that's not necessarily necessary. Yes, ma'am.
Okay, I'm confused as to why you had to do that. Change it to x squared minus 1 to x minus 1.
So why did we have to change x squared minus 1 into these two? Because your directions are going to be factored completely. And if you stop right here, it's factored, but not completely, because that is the difference of squares, which is what we talked about last time. Okay? Fair enough? Okay? Ask me a question. You okay with this? Yes, sir. this is difference of squares because these two came from that one. Where did this one come from? I just rewrote that one, right? So even when I wrote it, I covered it up because I didn't want you to think I was using it. When I factor the difference of squares, I get the x plus 1, x minus 1. And then this x minus 1 came from the fact that that was what was common in these two terms that I factored out. Okay? Good question. All good questions today, guys. All good questions. Good focus. I appreciate that. Any questions? We good?